revisit this problem over here, only because I want to be a little bit more specific. So I'm talking about the last question, right? So and the way we discuss in class is fine. I just want to show you the easier way. But in order to do the easier way, you have to sort of understand what we did in class. So 12 red, 8 blue, gives me a total of 20. So I need to write that down. The probability of at least one of the marbles is red. So when you're selecting two, you're picking two marbles and you're not returning the first. So you keep it, right? So our total is going to change. So you got to be aware. So at least one of the marbles is red. There's three possibilities. You take the first one is blue. The second one is red, right? That's at least one red. Another situation that we can do is this first one is red and the second one is blue. And the other situation that we have is the first one is red and the second is red. So there are all the possibilities. Okay, and then let me give you the fraction. So blue is, so be 8 out of 20 times 12 out of 19. So that's the first one. Plus the second case is where the first one is red, so 12 out of 20 times 8 out of 19. And third one is where both are red, so it'd be 12 out of 20 times 11 out of 19. And you would add that. So that's, and we got our answer, right? And I also showed you another way of doing this, which is, now the complement, understand what the complement is, right? It's the, I guess, the chance of raining tomorrow is 20%. The chance of not raining tomorrow is 80%. So these are complements. And they will always add up to 100% or 1, right? Depending on the notation that you're using. So the way I had showed it in class is the easier way, or shorter, not easier, the shorter way of doing it was to, from 1, which is 100%, subtract the probability of getting 2 blues. Right, so if you subtract the probability of getting 2 blues, whatever's left over has to be a blue and the red, a red and the blue, and a red and the red. So the complement of getting 2 blues, what's everything that's not 2 blues? Everything that's not 2 blues would be a red and the red, a red and the blue, and the blue and the red. So that's why this works. Okay, but in order for you to understand this, you would have to know that the complement of taking 2 blues is made up of 3 parts: blue and the red, red and the blue, and the red and the red. So that's the complement, right? So we can even write P of B and R plus P of R and B plus P of red and red. So if you take all those, right, I'll put brackets over here, plus the probability of blue and blue, because these 3 events and this event are complements, it should give you 100%. Give it a shot. Take a few moments and work that out. So that's that for that. So now let's go to our assigned problems. Assigned problems were not that complicated, I hope. 1, so we have a cube and a penny toss. How many elements does sample space consist of an even number and tail? So if you roll this, what of all the possible outcomes, how many of them will have an even number and tail? You don't have to draw a tree diagram. I'm just going to. So if you, roll the cube, we can get a 1, we can get a 2, we can get a 3, and then I'm going to do a little better. 1, 2, 3, 4, 5, and 6, right? Those are all the possible things that can happen. Then if you roll a 1, you can get a heads and tail. With a 2, you can also get a heads and tail. 3, you can also get a heads and tail, and so forth and so forth. So the possible outcomes would be 1 heads, 1 tail, 2 heads, 2 tails, 3 heads, 3 tails, 4 heads, 4 tails, 5 heads, 5 tails, 6 heads, 6 tails. of all the possible outcomes, which there are 8 of them, 1, 2, 2, 4, 6, 8, 10, 12, right? How many of those are even numbered? Even and what? An even and tail. So here's an even and tail, here's an even and tail, and here's an even tail. So 3 of them would have an even and a tail. Okay, they have 3 children born in 3 different years. Draw a tree diagram showing all the possibilities of kids they could have gotten. They could have gotten a boy, boy, girl, a boy, girl, girl, a girl, boy, girl, etc., etc., etc. Right, and what's the probability that they had 3 boys? So this is no different than heads or 3 coins, right? Being flipped. What are all the possibilities? Now, this one, let me write this: first child, second child, third child, my sample space. The first child is a boy. The second child could have been a boy or a girl. The first child was a boy and the second was a boy. The third child could have been a boy or a girl. First child was a boy, the second was a girl, the third child could have been a boy or a girl. If the first child was a girl, then the second child could have been a boy or a girl. And then if the first child was a girl, the second was a boy, you could have had a boy or a girl as well. And likewise for the third. So this is heads and tails, right? Coin, 2 different outcomes, and if we list them, so the children could have been a boy, 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 girl, boy, girl, boy, boy, girl, 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 boy, boy, girl, boy, girl, 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 boy, girl, girl, girl. So out of them, probability of them having 3 boys was 1 out of 8. 3. Create a little confusion. So you flip a coin. If you get heads, then the next, so imagine the game. If you get heads, then you're going to spin a spinner. And you can have any of these things happening. So you can have a heads with number 1, heads and 2, heads and 3, heads and 4, etc. But if you flip the coin and you got a tail, you don't get to spin a spinner. You get to flip a coin again. So with that, you can either have tails and tails or tails and heads. What are the outcomes that are possible? Well, H1, H2, H3, H4, H5, H6, T and T and T and H. Those are all the possible outcomes. 4, depending on how you see the problem, you can do it in 2 different ways. So what's the probability of not red? The probability of not red, well, let's find the probability of red. So the probability of red is 1, 2, 3 out of 5. What's the probability of not red? It would be the complement of 3/5, which would have been, 3/8. 1, 2, 3, 4, yeah, 3/8 would have been 5/8. You could have done it that way. Find the probability of actually getting red and then figuring out the complement, or just right off the bat. What's the probability of not red? So it means that you can land anything but red. Anything but red would be green, yellow, white, purple, blue. 1, 2, 3, 4, 5 out of 8. Your choice. Here we have a dartboard squared. So what's the probability that when you throw the dart, it lands on that white area? Well, the big square is a 40 by 40, which means the area is 1600, right? Because you multiply 40 times 40. The smaller square is a 15 by 15, so if you multiply 40 meters, if you multiply 15 by 15, you get 225. So if we take the area of the big square and subtract the area of the small square, we get 1600 minus 225. So the non-shaded area, 1600 minus 225 is 1375. So this white area occupies 1,375 inches squared. So if you throw the dart, what's the probability that it lands in that area? Would be the area of the white square over the total area, and the total area is 1600. Feel free to simplify that. Mary chooses an integer at random, From 1 to 6, what's the probability that you choose a prime number? Well, 1, 2, 3, 4, 5, 6. My prime numbers are 2, 5, and 3. So the probability of that happening would be 3 out of 6. 7. 7, okay. If the probability that rains on Thursday is 5, 6, again, just talked about complements, so the probability that it will rain on Thursday is 5, 6. The probability it will not rain will be the complement of 5, 6, which is 1, 6. 14, and here are your multiple choices. If you roll a die, which one is least likely to happen? Well, an odd number is half. An even number is half. So you have a 50% chance of happening. A number less than 6 would be 4 out of 6, right? No, sorry, less than 6 would be 4, 3, 2, 1, which is 4 out of 6, I'm correct, or 2/3. And the probability of rolling a number greater than 4 would be 2 out of 6, or 1/3. So which of these 4 is the least likely to happen? That one. We have a bookshelf. There's 6 mystery books and 3 biographies. You select 2 at random. You put it back. You don't put them back. What's the probability both are mystery? So P of M and M. So if you select a mystery on the first try, it would be 6 out of 9. On the second try, it would be 5 out of 8 because you don't put the mystery book back. So now you have 5 mystery books, and we have 1 less in total, 5 over 8. So simplify 2/3, 1, 4. That gives you 5 out of 12 chance. But if you want to pick a mystery and then a biography, so mystery and then a biography, probability of getting a mystery book is 6 out of 9, and the probability of getting a biography is, how many biographies are there? 3 out of, again, remember, once you pick one, you don't return, so the total is 8. Simplify again, that's 2/3. This is 1 and this is 4. This simplifies this, so you have a 1/4 chance of doing that. 6 black balls and 4 white, so that makes it a 10 total. But selecting, it's probably selecting a black ball, really. So it's probably selecting a black ball is P of B, which is 6 over 10, or 3/5. Is that it? Really? Huh. Okay. We have a dice again. What's the probability that a number less than 3 will occur? Less than 3 would be 1 and 2, so we have a 2. P less than 3 would be 2 out of 6, or 1/3. 3 roses. There are 5 roses, sorry, 3 roses. Oh, 3 roses will be selected. Okay. But there are 5 of them. Okay. How many different 3 rose selections can be formed from the 5 rows? So you want to take 3. Right? So in this first spot, you have 5 choices. If you select 1 and you go back and now you're selecting your second rows, you don't have 5 choices anymore. You have 4 to choose from. And when you go back to select your third rows, you don't have 4 because 2 of them are gone, so you have 3 choices. So we have 5 times 4 is 20 times 3. There's 120 different row selections that you can pick. What is the probability that 3 roses selected at random will contain 1 red, 1 white, and 1 pink? Well, what's the probability of getting a red rose? Would be 1 out of 6. What's the probability of getting a white rose? Well, it'd be 1 out of 5 because the red rose was already selected, right? And what's the probability of getting a pink rose? It'd still be 1, but out of 4 because the red and the white has already been selected. So this is, I don't know, 1 out of 1 over 20. What's the probability that 3 roses selected at random will not contain an orange rose? So you select 3 roses again. Right. What's the probability? So let's write the colors out. We have a red, a white, a yellow, orange, and the pink. So we don't want orange. Okay, so we can't, and I'm going to highlight that. We can't select the orange. So what's the probability that I select anything but the orange? So I have 1, 2, 3, 4 choices out of 5. I can select any of them but the orange. So let's say I happen to get the red. I'm going to go back into the remaining flowers and pick another one that's not orange. So I have now 3 selection out of, the red doesn't count anymore, out of 4. Let's say I got the white rose. I can't pick that anymore. So when I go for my last flower, the probability of selecting something that's not orange would be 2 out of how many total? 3. Let's simplify this. This and this goes away, this and this goes away. So there's a 2/5 chance of that happening. Not bad. 19. We have 5 green marbles and 3 orange. We're getting a marble and we're putting it back in the bag. So this is independent, right? Because the total will not change because you're returning it. So a marble is drawn, drop bag in the bag. Another marble is drawn, drop bag in the bag. So basically the bag is intact. Both marbles were green. Now we're going to select another marble. What's the probability that it's orange? Well, it's just 3 out of 8, right? Because there's 3 orange marbles and 8 in total because everything was put back. Now this is probably fundamental counting principle. So if you had went to deli, $5.99, you get to get a sandwich. You can choose 1 cheese, 1 condiment, and 1 type of bread. How many different sandwiches could you select from? Well, right, number of choices times the number of choices and next times the number of choices and next. So for cheese, there were 5 selections. For condiments, there were 2 condiments like ketchup, mayo, mustard, and 3 bread choices. So there was a total of 30 possible different sandwiches you can make with that. Okay. You can always make a tree diagram, right? Right. So if you want the sample space. There's an ice cream store. There's 16 different flavors of ice cream, 3 types of syrups, and 7 types of sprinkles. So if you bought an ice cream and you can only pick 1 from each category, how many different types of ice creams could you make? Well, from the flavors, I can pick 16. From the syrups, I can pick 3, and from the sprinkles, I pick 7. So whatever that is. 16 times 21, 336. Okay. Where am I? From how many 8-digit numbers can be formed if the leading digit cannot be 0 and the last one cannot be 1? So 8-digit numbers. So 1, 2, 3, 4, 5, 6, 7, 8. So this one, it cannot be a 0. Here, so let's put the numbers 1, 3, 4, 5, 6, 7, 8, 9. So the first in the leading spot, it can't be a 0. Is that what he said? It cannot be a 0. So I have 9 choices. For the second spot, no restriction, so I have 10 choices. 10 choices here, 10 choices, 10 choices, 10 choices, 10 choices. But for the last spot, it can't be a 1. So again, if it can't be a 1, I'm still left with 9 choices. So the total number of digits that I can create is 9 to the second power times 10 to the 1, 2, 3, 4, 5, 6. How many positive odd integers can be made using the word using the numbers 3, 4, 6? 6, 8, and 0. Well, if it's less than 10,000, it can't be 10,000, so it has to be 9,999 going down. So we have 4 digits, right? If it's going to be even, hang on a second, we have the 4 digits. Right, that's a group of numbers that we can write. We have the 3 digits, we have the 2 digits, and we have the 1 digit. So for this 4-digit group, what do we say? It has to be what is it? Positive odd. So if it's positive odd, the 3 has to be here, right? So I only have one choice for that spot. So the 3 has to be here. So for this one, how many spots do I have? Well, I have 3, 4, 6, and 8. Can I repeat the numbers? Shoot. Say I can repeat the numbers. Let's do this assuming I can repeat the numbers. Well, let's try it out. So for this first spot, I can use a 3, a 4, 6, and an 8, right? I can't use a 0. So I have 4 choices. For here, I would have 5 choices. For here, I would also have 5 choices. And for the last one, I only have 1 choice. It has to be a 3, so I'm going to actually take that out. And I'll erase this. I have 1 choice because it has to be a 3. So if I multiply that, I get 20. 20 times 5 is 100. So there's 100 over here, 100 choices. For this one here, it's a 3-digit number. This one has to be a 3, so I only have 1 choice here. For these two, right? For this one, I have a choice between 3, 4, 6, 8. I have 4 choices again. It can't be a 0, right? And this one, I have 5 choices because I can put a 3, a 4, a 6, an 8, and a 0. And how many choices is that? 20. For 2-digit numbers, well, this has to be a 3, so there's only 1 choice here. But for here, I can put a 3, a 4, a 6, or an 8. So I have 4 choices, and that gives me 4. And for single digits, well, I can only put a 3 because that's the only one that's going to make it, odd. There's only 1 choice. All right. So it's 120. 100 plus 20 plus 4 plus 1, and that gives me 125. So there's 125 choices. So this one is a little tricky because you have to think about, your 4-digit numbers, your 3-digit numbers, your 2-digit numbers, and your 1-digit number. Which is going to lead us to 24, which is the same thing. How many license plates of 3 symbols, letters, and digits can be made using at least 2 letters for each? Well, think about it. This could be a letter, and a digit, right? So letter, a digit. So I had 26 choices here, 26 choices here, and 10 choices here because it's 0. But I can also, the problem is I can also, we're talking about license plates. Well, it doesn't say it has to start with a letter or must start with a letter or digits has to be at the end. So another license plate that I can make a letter, digit, and a letter, which would be 26 times 10 times 26. Am I forgetting? It could have also been a digit, letter. Oops. Digit, letter. 1 second. Hello. Yep. Hi. Yes, I do. Thank you. Guys, well, you guys obviously can pause, but let me write that this is 10, this is 26. I have a phone call to take. So, because I don't want to restart again, I'm gonna. Is there any other possibility? Let's see. Oh, sorry, guys. 26 times 26 times 10. which is 6,760. Hi, doctor. It's Alex at this time. Yeah. Got it. Okay. Yes, I will see you next month because it's my turn. My wife and I will see you next month. Okay. 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 Thank you, Doc. Have a good day. All right. Sorry about that, guys. My mom's yearly checkup came back. What am I missing? Um, oh, so these are the three different combinations, right? So this would be also obviously 6,760. This is also 6,760. And I knew I forgot. And there's one more um, scenario that can happen. It doesn't say, and then you gotta just, I guess, think a little bit. Wish the question was a little more specific, but the other option that can have, you can have a letter, and a letter, because it says at least two, right? So why would they say that if this scenario couldn't happen, right? So the other scenario would be 26. You have 26 choices, 26 choices. So you can make a license plate with three letters, and that takes us to 17,576. So the total here, plus 6760 plus 67660 plus 6760. Enter. So that's going to take us to a total. There's 37,856 different license plates, assuming all these four scenarios. Okay? Because definitely a license plate that says AA1 is definitely different than A1A. Okay, makes sense, which is also different than 1AA, which is obviously different than AA. Okay, so just something that you have to keep in mind. Taking a survey at Taco Bell. For the first 5 questions, there's 5 questions. You can answer below average, average, or above average. So you have 3 choices. So think about 5 multiple choice questions, right? Each of them had 3 choices. So for the first question, you had 3 choices. For the second, you had 3 choices. The third, you had 3 choices. 3 choices. And the last 3 questions are the most question, right? It's the last long survey. And the last three questions in the Taco Bell is sending, hopefully for a free taco. The last three questions, you can either say agree or disagree, so you only had two choices. So the total, how many total outcomes are there for this survey? Well, 3, and I'm just going to leave it in exponential form. 2 to the 5th times 2 to the 3rd, and that is whatever that is. Okay. In a standard deck of cards, how many ways can you pick a king? Well, you can pick a king, a heart, and then a 5. Well, you can pick a king 4 different ways. A heart would be 13, and then a 5 would be 5 because there's 4 suits, right? So that would be 16 times 13, which is 208 ways, provided you put the cards in the back of the deck. Okay. All right. So again, if you're comfortable with this, I think you're doing very, very well. This probability. There's a little bit more we got to talk about. Theoretical probability. What do you call it? Theoretical experimental probability, and then we have a little bit of permutations and not a little bit, but yeah, permutations and combinations to also take care of.